This week in the classroom, we're going to be familiarizing the students with how to determine the slope using a rectangular coordinate system. But before I start, let me give a quick review. When we did cover this earlier this year, I taught the children that on a graphing system like this, that this number is +1, this is +2, this is +3, and so on. Going to the left, it was -1, -2, -3. Okay, and that was the x-axis. The run is the x-axis. The rise was +1, +2, +3, and then going down was -1, -2, -3, and so on. Okay, and that's where we're going to start. This is what they'll use to determine the slope of a line. Now, for this week, we won't be starting off with the x-intercept or the y-intercept. For those of you that are familiar with this, we'll just be giving them an arbitrary starting point. And basically, the way this works is we'll set up a fraction, more or less. And the number on the top will determine whether our slope is going to go up or down, whether it will be a positive or negative slope. And for our argument's sake, let's just put a 2 there for right now. We call this the rise. The rise is on top. Let's say that we have a run of 3. The run, in this case, is going to go to the right. This is called a run. So we have rise, run. These are the two components in determining a slope. Now let's say if we start a starting point of right here. Basically what's done in order to determine the slope is that we count. +2, that would be 1, 2 spaces up, and 3 to the right. 1, 2, 3. And then we make our next point. To continue, we would do the same thing. We'd start from this point now, and we'd go up 1, 2, and then 1, 2, 3 to the right. And that would be our next point. And then when we were all done, we would join the dots together, and now we have a slope. So again, the work that we did where we counted up and over is just that. It's just the work. It's not part of the slope. It's just how we determine where the coordinates are. Once we connect them, then we have the slope. This one is called a positive slope. And the reason it's called positive is because going from left to right, it's rising. It's going upward. We know that also because the numerator is a positive number. If, for instance, the rise had been a negative number like this, then we'd have counted from here, we'd have counted down 2, and still to the right 3. And that would be where our next coordinate would be. And then from that spot we would count down 2 again and over 3, and here would be our next one. In that case, we would have formed a line that goes like this, a slope that goes like this, and we call that a negative slope because it's dropping from left to right. Okay, and again, negative because we have a -2 right here. For the time being, we won't have negative numbers on the denominator because I like to start off by teaching the children that the run goes to the right. You know, it's not a big deal to calculate it to the left or to figure it out to the left, but it's easier to teach with them having something that they can hang on to consistently. The rise could be either up or down, depending if it's positive or negative. The run, for the time being, will always be positive and going to the right. Now, on testing, they could be asked to determine the slope based on the figure that they see. In that case, what they're being asked to do is to come up with the rise and the run. All right? And so the way I've taught them to do this is to get started like this, having your little fractions bar, and then count from the first coordinate. From here, we went up 1, 2, 3. So the rise is 3, and from there the run is 1, 3, 1. Now the rest of them we might go ahead and test. We might just double check 1, 2, 3, and 1, and 1, 2, 3, and 1, just to double check and see that they're correct. But that's basically it. Now that would be, they would see the figure already, the slope would be drawn, and they would have to go ahead and just determine, what the numerator and denominator needs to be in order to express what they see. Okay, 2 other things really quick as far as classifying slope. a line that has a 0, say 3, 0 numerator is no slope. The reason is because, let's say we were doing that and we were going to graph it, we have a starting point of this, we don't go up or down according to that, and we go over 3. And we don't go up or down, and we go over 3. You know, we have a run of 3, a rise of nothing. Eventually, you wind up with a line like that, no slope. Okay? Another possibility would be having a 0 in the denominator. In which case, what we're saying is, starting at this point, we rise 2 and don't run in either direction. We rise 2 and don't run in either direction. We wind up with a line like this. We call this undefined. Undefined. It's similar to division by 0, which we call undefined also, but if this were a slope like this, well, you need some sort of a slope, so to speak, for it to be a slope. This is not yet defined. I told the kids to think of it as a skateboard ramp, okay? If they have a slope, they have something they can ride. On this wouldn't be a slope. This would be an accident. That's about all we have for today. That's about all we're going to be doing this week, is just working with these slope things and getting them the idea of how to do this. As always, feel free to watch the video again, and don't hesitate to call me if you need any extra help, and I thank you for watching my video.